Hi guys, welcome back to this series on interest and depreciation, and in this video we're going to be looking at the examples of compound interest. Now the questions we're going to be doing in this video come from the New Century Maths Advanced textbook for Year 10. We're going to be doing exercise 2.05, the compound interest formula. In this video we're going to be doing question 4, the last question of question 5, and question 10, which is quite a big one, so let's get into it. Okay, question 4. Find the amount of interest earned on $1 million invested at 14.9% per annum for 6 years. So the important parts of this question here, I can see straight away, are the amount of interest earned. So remember, with our formula, it gives us A at the start, which is the P plus I. So the interest earned does not include P. So we're going to have to remember that. I can see that our principal is going to be $1 million and our rate is going to be 14.9 per annum. It's getting paid once a year, I'm assuming, and we're going for 6 years. So this should be pretty straightforward, just putting it into our formula and then figuring out what the amount of interest is. So remembering our formula is A, so our amount at the end is equal to the principal plus 1 times 1 plus the rate in decimal form to the power of n. So filling this in, we know that our principal is going to be 1 million. So remember, a million is 1 with 6 zeros. And then if you're not sure what a million, billion, trillion looks like, you just keep adding 3 zeros. So it goes 1,000, then with an extra 3 goes million, then with an extra 3 billion, then with an extra 3 trillion, then an extra 3 quadrillion, etc. So we got that, and now we got 1 plus, and remember we want this in decimal form, so we want 14.9 divided by 100 because it's percent. So that's going to give us 0.149, and that's going to be in years, that's per annum. And we're happy days because our time period is going to be 6, which is in years as well. So this is per annum, this is per annum, we're good to go. So putting this into our calculator, first putting in 1.149 to the power of 6, and then timesing it by 1 million, we get an answer of $2,301,018.82. So as you can see, that big principal there and also this large rate over a long period of time has contributed to almost 2 and a bit times his money. So that's pretty good for an investment. But what we want is we don't want this total end amount. We want just the interest. So what do we have to do? We have to minus 1 million. And you should be able to see this just in your head. Then we just need to cross out that 2 and put a 1. So we have $1,301,018.82. So pretty good work there. Okay, so question 6F, we're going to calculate both the total amount, so our A, and the interest earned, which is just going to be our I, like we did in the last one, for $4,900 over 1 year at 5.5% per annum, compounded, spelt wrong, daily. So we can see that this rate has been given to us in years, because per annum means years, but we want to try and find what that is when it's broken into its daily bits. So that's the first thing we're going to need to do. We're going to try and find our daily rate. So if we're getting 5.5% for the whole year, we're going to try and either divide this by 365, the amount of days in a year, or 365.25. Either of these could be right, depending on what your teacher wants you to do. But for this one, we're just going to be smart and do 365.25. So putting that in our calculator, we get 0.015%. So because this is percent, and remember I've rounded this, so the answers may not be exactly the same as the textbook. We're going to again divide this by 100 because this percent again means divide by 100, and we're going to get our decimal form of 0.00015 per day, percent per day. So we get this 5.5% for the whole year, but if we're paying that out every day, bit by bit, then that's going to mean we're going to pay 0.0015 in decimal form every day. So we have our R, so we're going to put our 1 plus in front of this. Now we need to try and find our N. So we know that it's only 1 year, so how many days are there in a year? We're going to say that there's 365.25, accounting for leap years, even though it would depend on whether this is a leap year or not. We're just being a little bit cheeky here. And putting our principal in front of 4,900. We can then put that in our calculator and we get a total answer of $5,175.92. Now the answers in the textbook might be a little bit different because they may not have used this 0.25 and they may not have rounded that to two significant figures like we have here. So that would be the reason this is different, but if your teacher sees this working out in an exam, you should be fine. Okay, so question 10. Zoe is 5 years old and her parents invest $15,000 for her high school education expenses in an account that earns 6% per annum over 7 years. Calculate the interest if compounded yearly, monthly, quarterly. Or this should be... Okay, fuck it. I'm going to redo it. Okay, so question 10. Zoe is 5 years old. Her parents invest $15,000 for her high school education expenses in an account that earns 6% per annum over 7 years. Calculate the interest if compounded yearly, every 6 months, quarterly, or monthly. And question B is which compounding period should be chosen and why? So we're going to start off with question B because we sort of covered this in our explanation video that we did before this one. So usually if the rate's the same and the amount's the same, then what you want to choose is you want to choose the smallest period, because then the more amount of times you get paid your interest, the more dollars that they have to pay interest on. So in this case, we're going to know that the smallest period here is monthly, because every month you're going to get a little amount of interest, and then the next month they're going to have to pay interest on the original amount plus the interest that's already been paid. So we know the answer to question B already. So now we're going to have to go in and do each one of these different compounding periods. So we should be able to say that yearly will have the least amount of interest. 6 months should have the second most. 6 months should have the second least. Quarterly the second most, and monthly the most amount of interest that you earn. So let's go in and do these. So remembering our formula is A equals P1 plus R to the N. And the only thing we really have to remember here is that the rate and the N need to be in the same format. So if we have a rate per annum, then the number needs to be in years. If we have a rate in per every 6 months, then the number needs to be the amount of 6 month periods. So we know that this 15,000 here is not going to change for any of them, but the rate and the N are going to change. Now I'm not going to go through and put every single one in my calculator, but what I am going to go through and calculate all the R's and N's, and you can do the rest yourself. So going for yearly, we know that we have 6% per annum over 7 years. So we don't really need to change any of that, but we do need to change this into decimal form. And we do know that percent means divide by 100. So we have 0.06 here for our R, and we're going to have 7 up here because it's going 7 years. Now that is in per annum format, and this is in years format, so that should be all good. So now every 6 months. So I know we're getting 6% every year. Now if we're paying that every half year, then we're going to get paid 3% twice a year. So this is going to be 0.03. Remember, that's 3% in decimal form. And we're going to get paid this double the amount of times, because we're getting paid twice a year. So all we need to do is times this by 2, and we had 7 before, so we're going to have 14 up there. If you put that in your calculator, you should be able to get the A, and then minusing 15,000, get the P. So quarterly now. Now quarterly means it's getting paid 4 times a year. So every 6 months means every half a year. This means every quarter of a year. So we're going to take a quarter of the original rate. So we're going to have 6 over 4, which is going to give us 2% every quarter, which then converting that into decimal form is going to give us 0.02. And we're going to try and get the amount of quarters. So how many quarters are there in 7 years? So 7 times 4 is going to give us 28. So you can put that in your calculator as well. Now our last one, which is going to be monthly. So remember there's 12 months in a year. So we're going to take this original one of 6% per year. And then we're going to divide that by 12 because we want it in monthly bits. And if we can see, we have 0.5 or a half of percent. And then converting that into percent forms, we're going to have 0.005. in decimal form, and we're going to find out how many months there are in 7 years. So we're going to do 7 times 12, which is going to give us 84, and you can put that in your calculator to get your A, and you should be able to get the rest of the answers. So that's it for exercise 2.05, and we'll be going into depreciation in the next episode.